Ooh, onward and upwards, friends. Next up on the docket is hydropower. So hydropower, power from dams. So you see that we make really large reservoirs that are behind very, very big dams to create them. And here's an aerial shot showing how extensive those reservoirs can be. So that's what defines a hydropower dam. So hydropower, you build a high dam across a large river, let the water build up behind it into a reservoir, and then you let that water flow through large pipes that then again turn turbines to make electricity, just like has been true with the other electrical generating apparatuses that I've discussed. So who leads the world in this? Norway. Norway gets the vast majority of their electricity from hydropower. The rest of the world only 16%, and the US is about 7%. And that 7 is a pretty consistent number. Since the 1970s, we really haven't increased the amount of hydroelectric power in the United States. Here's a picture of how that process works. Here's your large dam, built mostly, usually always of concrete. You have these gateways or pipes that they can open and close to determine how much water they want to allow in. That water then goes through a turbine system that spins and then exits out the outflow at the bottom into the river below. That spinning generates electricity that then goes through a transformer and sent down power lines. So we have a small one of these that helps out Buffalo's energy supplies. Yellowtail Dam up in Hardin, Montana is the largest one in the area, and so they're common throughout the United States. What are some advantages and disadvantages? Advantages: lots of good quality energy made. Very efficient, 80% efficient on energy. They have a large untapped potential. There's lots of places we could add hydropower if we wanted to. It's very low cost. You get a lot of energy for very little expense. They last for a really long time. There's no CO2 emitted from it. They also help with flood and control by providing damming. They provide irrigation water, and they create fishing and recreational areas. But some bad stuff about it. Initial high costs to build them. So construction costs are really high. They have a huge environmental impact in the fact that they flood a whole big area to make the reservoir and destroy that environment. Those environmental costs don't go into the marketplace. The high CO2, there's a higher CO2 emitted because of biologic and biomass decay in shallow reservoirs. There's danger if they ever collapse or break. It moves people out of the way. In China, where they made the Three Gorges Dam, they had to move over 1 million people out of that valley in order to put in the Three Gorges, which is the largest hydropower, largest dam in history. It decreases fish harvest below the dam, so it messes with the cycle of fish. And it changes the way that fertilizers and stuff flow down through the river system. So it affects the whole health of the river ecosystem, the riparian ecosystem. There's another way to use hydropower, and that is through ocean tides and waves. So ocean tides and waves, and also temperature differences in the ocean, are all ways that we can actually generate electricity as well. And so the temperature difference between the surface and the bottom are different, and you can use those differences in temperatures to generate electricity. You can use the action of waves pushing on like large paddles that can generate electricity, and then the tides as they rise and fall can be used to generate electricity. But it's not applicable in lots of places. First of all, there's very few sites that are suitable and have enough movement in tides, waves, things like that to create this situation. The cost of installing them is extremely expensive, and because it involves salt water, the equipment undergoes a lot of corrosion. Really, there's only 2 major places that actual tidal energy exists and is utilized. Tidal energy dams, and this is a picture of one, where when the water flows in, they can trap the water and then have it, as it flows out, they can use it to produce electricity, kind of like a conventional dammed river. And one is in France, and the other one's up in Nova Scotia. And the reason why it's so effective there is they have really high tidal movements, up to 63 feet. So not going to solve a lot of problems around the world because of the limited places and expenses of it, but it is another option for producing electricity. That's it for now. Bye-bye.